have people who like their job and people who don't. Well, no, you have people who are fired and people who weren't. So you're comparing like.
I thought it's number of employees in each group who were terminated.
Yeah, but it's in each group that were that. But it's those numbers. Are they not percentages?
Okay, did you let him in? Okay. I don't know if I have any right now, so sorry. Okay, so sorry. My kids haven't seen me all day. I literally came in, used the bathroom, and started my computer. That's my day. So sorry. Where did I interrupt you guys at so I can catch up?
3. So we're still on 3, sorry.
No, good. I'm kind of glad.
So Ruth's probably right. I'm just confused.
That's not the best way to start it off.
Okay, so
test of 2 proportions is what Ruth is saying for question 3. Is that what you're getting?
I get really confused on these too. So let me just read that. You're an attorney, you want to determine
if it's what confuses me is that the proportions is supposed to be categorical, whereas these sound like numbers. Like number of people who got fired in this group and number in the other one. So to me, I would have said it was like a independent sample t-test or something like that. But I'm thinking we should probably trust Ruth.
I don't know.
Well, you have 40, so they're 40 years of age or younger or older, but it says who were terminated. So the question would be, were they terminated or were they not, which would be quantitative, right? Because it would be a yes or a no.
Oh, you mean categorical?
Yes. Oh, yeah, sorry. Yeah. I'm glad you knew what I meant.
Yeah, because you're doing percentages of yes or no's.
I thought it was, reported the number. So yes, it is yes. Oh. Okay, you're right. Test of 2 proportions.
Okay, and then.
So help me out. What? I'm confused now.
You're right. It's a yes or no, so it's a category. So it's the proportions, and because you're comparing 2 proportions, that's the one.
Let me share my screen while I can. Okay, so then for question 4, it was 1 proportion. Because they're not really saying weight, it's just heavy or not, you know? 5.
Okay, so 4, sorry, so 4 you're saying is?
Test of 1 proportion.
Okay.
Is what I think.
Well, proportion though. So proportions, that isn't. But you're doing it to the population like we were doing early on, right? Random sample, 248 were heavy.
You're saying if they're heavy or not.
Yeah, I'm leaning towards the 1 proportion because it sounds like the problems we did, not this last one, but the one in question 18. Oh, wait.
Okay.
Cool. 5 paired sample T.
Okay, that's what I had. I get really confused, so I hate to even say what I'm thinking, I swear.
Well, because we want to see if some locks are easier, so it matters which locks are paired with which ones.
Yes, and that's what I got on that one too.
Okay. And then for question 6, paired samples T, confidence interval. Why did I say that again? Oh, yeah. So we're doing confidence interval because that's what it asks, which confidence interval will be the best. And I said paired because we're comparing different houses for mortgages. I gotta go, but this was fun. Thank you guys. I'll see you guys on Thursday.
Okay.
I'll see you. I love you.
Thank you. Okay. This is where I struggle too, so I'm a little worried.
Yeah, I don't like these questions at all. Okay, a bank employs 2 appraisers. When approving borrowers for mortgages, it is imperative that the pair appraisers value the same types of properties. So,
Oh, I see what she said. Yeah, so it'd be paired samples T confidence because they are not dependent or independent. They're dependent on each other, right? Because
that's what I think it is, because they share, the thing they share is that they're both appraising the same house. That's what I think. That's why I think it's paired, because they're both appraising the 6 same houses. But the difference is that they're different people. So I think it's paired as well. Hopefully that's right.
Right. Oh, I'll be right back. Hang on just 1 second. Sorry.
Oh, you're good.
Okay, I'm so sorry. Sorry.
You're good.
I just need
You're
3.
good.
That's all. Just 3. I can be in like 5 different places at the same time. That would be so great.
That would be awesome.
Okay, so number 7, Wall Street Journal. Have you looked at this one yet on
So what I was getting for it, and if I'm wrong, it's okay, you can correct me. I got confidence interval for 2 proportions, and I think it's because, like, the same as what we were talking about earlier, whether they were satisfied or not satisfied. So a yes or a no. And because it's 2 proportions, because they're doing it for psychology majors and accounting majors. So that's why I thought 2 proportions.
I would agree with that too.
Okay. And then for question 8, the double stuffed Oreos. True.
We need to construct a confidence interval to estimate the true mean filling amount of double stuffed Oreos in order to compare it to the filling in regular Oreos. So wouldn't that be the paired samples T confidence? Because they're dependent on other. Would that be right? Because you'd have to have, what you find most appropriate? Because you want to know, we're supposed to have twice. Friends wants to know.
I mean, they're both Oreo cookies, and we're trying to see if it's actually double what the original is. So part of me wants to say they're kind of dependent, but the other part of me is like, I'm also in my head comparing it to when you sampled married couples And the only reason why they were dependent was because you can't take the wife separate from the husband or something like that.
So then it would be independent, right?
So would these Oreos be independent?
I don't know. I get so confused.
I guess we could try it, and if it's wrong, because I'm pretty sure it's either between the two. Because they're all Oreos, that's what makes it hard. Because they're all like, should be the same, I think. But
Okay.
I'll say independent for now.
What,
Well, what?
what if we look at quantitative sample t-test? One sample, two sample. We have a two sample t-test, which you could put variable one and variable. So I'm looking at the Excel spreadsheet. So.
Oh, to see which one would fit in it.
Yeah, to see one sample, paired sample, independent. So I think it's the independent samples T confidence interval. Because you need more than one sample, right? You have a sample of your regular Oreos and your sample of your double stuffed Oreos that you're comparing, right?
Mm-hmm.
So it's neither 1, 2, or 3, and it's not a proportion. So I think it's the independent. Does that make sense?
Yeah, I think you're right.
I could be totally wrong. Like with these, I get confused.
I'm leaning towards that too. Well, at first I was saying dependent, but then the more I thought about it with the married couple thing, I was like, okay, maybe independent. But
right, because you're not going to subtract one straight across from the other. You can just do it as a whole and compare one to the other. Right?
Yeah.
Okay. So.
And then the next one, 9.
Justifying the notion of the significance level of the hypothesis test. So is that?
I'm thinking first one so far.
That's what I have for my answer, but I don't know if it's right.
Although the one that says the probability of rejecting null hypothesis, whether it's true or not, seems kind of close. But I always thought you always assume null hypothesis is true unless rejected, which is what the significance level is. So I'm going to go with the first one.
I agree.
Oh, wait. We're getting the p-value mixed up with the level of significance?
I don't know, because I was thinking that 10 is D, the probability of rejecting.
Oh, yeah. It's low, you reject it. And okay, you're right.
I could be wrong. I don't trust myself.
I trust you. It sounds right.
I feel bad because I really didn't get very far. I got a lot of these that I didn't have to do math with, but I haven't done any of the math. So
that's where I'm at. So sorry, I'm not going to be able to help out much either. But
we'll walk each other through it. I always get this question wrong. So suppose you a 95% confidence interval for a mean and get 10 and 20. You've been told to report this by saying something like, we're 95% confident that the true mean is between 10 and 20. What does this mean? So I wanted to say it was D. But I think I get that wrong because of that chance word. It messes me up.
Yeah, I always thought that the chance word is not right. Like it's always like just 95% confidence.
Yeah.
But then when I don't pick chance, I get it wrong. And then when I do pick chance, I feel like no matter what I pick, I've always gotten it wrong.
Same.
So I'm just trying to like remember what I picked in the past.
Because 95% of the data are between 10 and 20. That doesn't That's not right. 95% of the sample means are between 10 and 20. That doesn't sound right either. So I'm confused. 95% of all 95%, that doesn't sound right either. So I don't know. I guess I just went with the one that sounded the least ridiculous.
So then there's a 95% chance the true mean is between 10 and 20.
Yeah, but I'm probably wrong because every time I pick that, I'm wrong.
Well, it sounds the best for me too. So I'll pick it and yeah.
Oh man. So what I probably should have is all of my formulas out somewhere, but I don't. Are you planning on sitting in on her 8:30 meeting to go over all the formulas and stuff that we're supposed to be using? Or
Is that today?
I think so. I think that's what I gathered from it was Tuesday at 8:30 or tomorrow at 2, which is impossible for me because I'll be in Vernal.
Oh, and I'll be at work. Dang it. I don't know. I probably should, but I'm thinking maybe I'll just go through all the past formulas. I don't know. How long is the meeting supposed to last, do you know?
I don't know. I think it will probably just depend on who's asking what questions and how far she gets with all of her formulas and stuff. And who knows?
I'll see, how, because I didn't look at this as much as I should have before our meeting. So depending on how we do with this, I think it's like I'm finding that I'm struggling, then, which I already am struggling, but if I struggle even more, then I'll probably sit in on it. Yeah.
So the listening population proportion or percentage of people in town who invest in the stock market is P equals 30 or 30%. So I don't know. When I was looking at this yesterday, it looked like it was a simple answer that it was a 0.30, but I don't
That's
know.
what I'm thinking it is.
Okay. I probably make it too difficult.
And then to find the standard. Oh, we did this recently, I feel like. Where is that?
So is that
I feel like we've done this where it's like the mean is always what they tell us it is, and then there's a
yes, simple. I know there's something obvious somewhere, I'm sure, but
I like vaguely remember it, so maybe I do need to sit in on those formulas.
standard. So I don't know. Oh, sample purport. What is the standard deviation of the distribution of the sample proportions? So this proportions, that's what we were just learning, right? Is proportion.
Yeah.
So yeah, I don't know why I'm having trouble with that.
Trying to pull up the textbook again. Can do that.
Okay, so I did the math and I figured this out actually. Sorry. And I didn't write that down how I got that. Oh, because that's the I think that's the P times 1 minus P over the sample size, which I came up with 0.0458, so it'd be B.
That's right. That sounds right. That formula. So you said P times 1 minus P over sample size?
Yes.
Okay.
At least I made a note of that. Goodness. Jeez.
Thank you. You're a lifesaver.
Oh, well, that's as far as I got with any of the math stuff. Oh, man. So standard the verbiage just throws me off. Distribution of sample. I'm just going to make a note to myself so I don't drive myself crazy with that same question. So it's P over N.
Wait, what did you get for your standard deviation?
Did I write that down wrong? 0.0458. So that'd round to 0.046.
So I'm getting, because we're still on question 13, right?
Yeah.
So it's 1 minus 0.3
Oh, and then I think is that
times 0.3
something is squared.
divided by 100.
The whole thing.
Oh, everything is squared.
Yep.
Okay, thanks. Sorry, that's getting.
That's my fault. I left out that small detail.
Oh yeah, 0.046. What I mean. Thank you.
No problem. Okay, so this is the point where I basically stopped.
Okay, and I think so I didn't get to this part before the meeting, but I think I know how to do it. So I think that this is where we do the why can't I think of words? Formula, that's the word, for the z-score, which is oh wait, no. That's for two proportions. Sorry. Let me go back to the one proportion one. Sorry, I have the wrong one pulled up.
No,
But I'm pretty sure I know how to do this one.
I'll look at my notes too. So this is proportion. Has statistics. So
Okay, so the z-score is like the value minus the mean over the standard deviation. So we already found our standard deviation, which is 0.046. But then we need to do the value over the mean, so that's 30%. Wait, but that's confusing to me because isn't the p hat, didn't we find that the value is the same as the mean? Because
it's the value minus the mean over the standard deviation. So then that would be 30. Would it be 30 minus 100 divided by your standard deviation? Is that what it's saying?
well, it's not. I don't think so because 100 isn't a mean. It's the it's the sample size.
Oh, I'm sorry.
Proportion less than 25. So is it the 0.25 minus 0.30 divided by 0.046?
Yes. Oh my goodness. Yes.
Is it the
over
And then you plug that into your normal probability applet, right? But you have to do less than. Yeah?
Yes.
Maybe? Okay.
So your z-score, for your z-score, did you get negative 1.087?
1 second. I had to scroll up to open the normal probability applet. And now I'm trying to scroll down to find the question we were on. Sorry.
No problem.
Wait, so I'm getting negative 1.087. Is that what you said?
So then it
Yeah.
would it'd be 0.139 is the probability.
139. Yeah. 0.139. Oh no, did my computer die? It shouldn't have. Can you still hear me?
Yep, I can still hear you. Hello? Hello?
Are you still there?
Are you there?
Yeah, can you hear me?
Yes.
Oh my gosh, I don't know what happened. My computer was plugged in and it just died. And I was like, it's plugged in. It should not have done that. Okay. I'm back now. I can't even remember what we were talking about. But luckily, none of my tabs closed down. Like, they're all right where we left it.
I'm so glad that was
Okay. What is the probability will be less than 0.25? That was 0.139, right?
Yes.
And then what were we talking about, like, right before it died?
Okay, so we're doing the confidence interval or whatever on this one, right?
Are we on question 15 now?
I think so.
What?
Yes. Yes. Okay, so that's the one with the awesome formula that's like p hat minus p hat 1 minus p hat 2. I just have to figure out I'm messing this up. Okay, so p hat 1 is x1 divided by n1. So we have to figure that out first, right? Divided into two groups. So our group 1 are the people who experience dizziness while taking Acupril. Okay, I have to pick this apart. Sorry. 15 received Acupril. So, okay, so P hat 1 is going to be 5. No, it's going to be 61.
Sorry. I'm not following along. I'm very well with what you're saying just because for some reason it sounds very robotic-y and it's hard to understand you.
Oh,
But I think it's probably my computer. It's been doing that. I'm sorry. In and out. But are you just figuring out the margin of error right now?
I think so. Although maybe I'm just doing this the hard way because I can put that in one of the awesome Excel spreadsheets, right?
Oh yeah, I forgot about that.
I know. I'm like, wait a minute. Why don't I take advantage?
Because I'm sitting here trying to figure it out too, but I forgot we could do that.
So if we're doing two proportions, yes, we are. So
Two proportions.
if you want, I can put it in my. If you'll read the information to me, I can put it into the Excel spreadsheet.
Okay. Yeah, because my Excel, I'm still waiting for that to open, so I don't mind reading it to you. Let me know what it's asking for first, because I don't see what it's asking for.
Okay, so it's x1 divided by n1. So how many people were dizzy in group 1? Was that 61?
61, yes.
And the sample size was 579?
Well, and then 61 out of 1,563 is the group 1 proportion. And then group 2, it's 15 people were dizzy out of 579.
Okay, so 15. Okay, I'm a little confused. So
it did say
0 in the experimental, but that's the total in the group, right?
Well, the total is 2,142, but then it was split up. So 1,563 received the Acupril, and out of that number, 61 people were dizzy.
Okay, so we want to
But out of the control group, this is 579, only 15.
Okay, so
sorry, I'm not doing a very good job reading it out to you, huh?
Well, I'm actually looking at it and I'm confused. So 2,142 were divided into two groups. 1,563 received Acupril. 579 received the okay. So then our first number is going to be 61 over 1,563.
Yes.
And the second number will be 15 over 579, right?
Yes.
Okay. Thank you. Sorry, sometimes I'm just a little darn slow. Okay. So P1 is a true proportion who, okay, so I have it in the right place.
Mm-hmm.
So create a 95%, which I already have. Lower and upper bounds below rounded to 3 decimals. So the margin of error for 95% confidence. interval. So remind me how we figure out.
So if they're giving you lower and upper bounds, then we can figure it out by just doing, so P1, 1 second. I could figure out what the mean is real quick.
Oh, yeah, actually, I think I have the margin of error. So we're doing inference for two proportions, right? Is that where we're? Oh no, we're not. Yeah, we are. I thought that.
So there is a formula that you can find out the margin of error, but with the Excel sheet, what I like doing is taking the upper bound and subtracting the mean away from that, and the mean is P1 minus P2.
Okay.
So
Was it P hat, right?
Yeah.
Okay, so all right, so then I would take, okay, I see what you're saying. So if I do,
So I have for the mean 0.013 as like the point estimate.
yep.
And then what did you have for the upper bound?
Oh, so for the sorry, I don't even know why I just did that. I'm a dork. Okay, so for the upper bound I have 0.029 and the lower bound I have negative 0.003.
Okay. So what we can do is we can take 0.029 minus 0.013. And I got 0.016. And then how we can test that is we can just do negative 0.003 plus 0.016.
What did you do?
0.013, and that's what I get. So yeah, for the margin of error, I got 0.016, and then the lower and upper bound they give us.
Wait, don't go yet. Okay, sorry, I have way too many things open. Okay, so for the margin of error, what did you get?
For the margin of error, I got 0.016.
Okay, so when I was in there with the Excel sheet, I think I confused myself because if I take 0.013 and I subtract it from 0.029, then I get 0.016. But if I take 0.013 and I don't know, how did you get the other 0.16?
So what I did was I did 0.029 minus our point estimate, which is 0.013, and then I got 0.016.
Okay, I got that. But
And
then
to test it, I take negative 0.003 and I add the margin of error, which is 0.016, and it should bring us back to our point estimate, which is 0.013.
Oh, I was taking I was taking our mean number. And okay, I'm with you. I got it. Sorry.
The reason why I don't take the mean and minus the lower bound is because a lot of times the lower bound is negative, and I'm the type of person where it just throws me off. It confuses me more. So then I just take the lower bound and add the the margin of error to get the point estimate instead of, yeah. Nope. Because I don't use negative numbers.
Okay, so did you get 16 and 17?
Yeah, so 16 was the negative 0.003,
Yes.
and then 17 is 0.029. And perform a hypothesis to see if the proportion of experimental group subjects are different.
Did that one? Oh, I didn't do that. Oh, I thought I did that one. Oh, a hypothesis test. Group subjects who experience dizziness is different.
It's just, I'm getting the first one. It's equal to and then not equal to, right?
Uh-huh. So the value of our test statistic is in our spreadsheet, right? So that's our Z-score. It's 1.458.
What did you say it was? It broke up again.
Oh, sorry, 1.458.
Is the test statistic?
Mm.
Great.
The p-value is 0.145.
Thank you so much. So the p-value is 0.145, and what was it was 0.05, so it's bigger.
So it's greater than, so we fail.
To reject it. Yeah. So if the null is equal to and we failed to reject it, means it basically is equal to. So is there sufficient evidence to conclude that the true proportion of people who experience them is different? So it's no, because I failed to reject. So it's the last.
Yeah, I would agree with that.
The word.
Oh no, your computer's breaking up. Or my
What was that? Sorry.
it was breaking up.
I got the last one. No, I failed to reject the null.
Same.
Okay. Awesome. What does this last say? Oh, this is a new thing.
Oh, okay.
This looks like it's going to be the chi thing, right?
The survey was conducted of randomly selected adults age 18 or older. They were asked, are you a morning person or a night? Oh, are you this or a night person? Yes, because is dependent or not, or is independent or not independent. Okay, so
we could plug this into Excel again, right?
Yep, absolutely. So would you want to read that to me and I'll put it in?
Sure, I'll do it as if we're reading again. So like I'll go across and then down to the bottom left again and go across.
Okay.
Let me know when you're ready.
Ready.
So it's 97 and then 177 and then 210 and then 210 again. And then down on the bottom row is 131, 164, 200, and 190.
Okay. Next row. Is there another row?
Nope, it's just between morning and evening. So it's just those two.
Okay, I have some information already in my sheet, so I'm going to delete it really fast so it doesn't mess it up. Okay.
You're good.
Conduct a test of independence. Calculate the test statistic for the hypothesis, assuming the requirements for the test are satisfied. The test statistic is 6.751. Does that sound right?
Guess so. That's what the Excel sheet's saying.
What's that?
I said, I guess so, if that's what the Excel sheet is saying.
Right.
And then 23 is calculate the p-value for this hypothesis test. Assume the requirements for the test are satisfied.
That is 0.080.
Okay. And for this, though, the requirements are satisfied. I know it's not asking this, but it is because it's over 5 in each cell, right?
Exactly.
Okay. I was more just asking that for me. So 8.080.
So
So it's still bigger, so we failed to reject, right?
yes. So fail to reject. So we do not, right? So no, the p-value is greater than 5. So we failed to reject it. So we did not reject it, right?
Yeah, and it's because the p-value is greater. So it's the third from the bottom, right?
Yes, that's what I have. Based on your results. So it's greater, so it's insufficient evidence to say that. I think it's the last one because your alternative hypothesis is not independent, where your null is independent. Does that make sense?
Yeah, I'm thinking the same thing as you. The last one. Wait, for some reason it's saying 23 is not answered, but I think it's just because I didn't save it. Okay, there, good. 25 and then 26. Oh, it's a new question. Darn it. I was hoping the ones that we plug it in, it can go as long as possible.
Okay, so a recent book noted 20% of all investment managers outperform the Dow Jones Industrial Average over a 5-year period of random sample. So managers outperformed. The P is the true proportion of investment managers. These so confuse me.
Is this back to the one proportion test?
It's one of the proportion tests, right?
It doesn't, but not the two proportion test, right?
I also don't think there's enough information to make it into a 2 proportion test, right?
Yeah, that's what I'm thinking. So it's out of 200. I'm just going to try to write down everything that we do know.
50 of these outperformed the Dow Jones Industrial Average, which was 20%. True proportion. So 50 out of 200, right? So let me go back to one proportion. So N is our 200.
Yeah.
Is the other. So we have 90%. The null hypothesis is the null hypothesis 0.20. No, I don't get that.
Wait, what question are you on?
Well, I'm just looking at the one sample z test for one proportion.
Can you share your screen with me so I can see it?
Yeah.
I guess I can pull up my Excel.
This up or something.
Wait, what?
Well, so you can see if I'm screwing this up.
No. So I can see what it's asking for because I don't have my Excel sheet up. I was gonna pull it up, but then when you offered to do it, I was like, oh, okay, I'll just read it to you then.
Okay, so see right here, we have our X, here's our N, here's our confidence level, but here's our null hypothesis.
Oh, shoot.
And then I'm down here with the one proportion B test. So I think I'm in the right place, right?
I think. Let me reread the question. Okay.
I'm trying to figure out where I'm at here. Oh, I'm in the wrong place again. I drive myself.
Okay, a recent book noted that only 20% of all investment managers outperform. So the null is 0.20.
Okay, that's what I was wondering, but I really didn't want to mess it up.
Phew, excuse me. Sorry.
Bless you.
Thank you.
So that actually looks a lot better because there's your z-score, your p-value. That looks a lot better.
But then
Okay.
I thought, sorry, I thought the alternative was then, the alternative was does not equal to. Does that make a difference or no?
Tell me again. The alternative is not equal to.
Because it's 20% is the null,
Uh-huh.
and then we're getting 0.25%. So our null is that our proportion that we're finding, our sample proportion is equal to the big proportion, right?
Oh, so you're saying I need to change this.
I think so. To not equal to, does that look right to you?
Not equal to random sample, graduated from one of the top 10 business programs.
Whew, hold on.
Investors who graduated, who outperformed. So wouldn't that be greater than?
Well, no, because it's
Proportion.
not saying who did bigger than this. It's saying these people did do better, but it's 0.20% compared to 0.25%.
You know, I was thinking better than or greater than 25%. Oh, the 50 over the 200, right?
Mm-hmm. Because it's already saying that 50 outperformed it. So I think it's saying like.
What does it change if I do that? Oh, it changes the p-value. Greater than, not equal to. Okay, well, either way, the confidence interval is the same, right? So even if I change greater than, yeah, no matter what, it stays the same. So here's our confidence interval. So the lower bound is 0.19. I don't know if we need a 190. I don't know. I leave the zeros off the end usually. And 0.310. Right? Did I enter all that correctly?
Looks right to me.
And it doesn't ask us our p-value or anything either, so that's okay. Okay, so suppose you'd been in charge of designing the study. What sample size would you need? I know what. I have that here.
Oh.
So our sample size is, so we need our z-score, and we have our, we don't have our margin of, margin of error is 2%.
Isn't 95% confidence mean the z-score is always 1.96?
Oh, yes, you're right. So it would be 1.96 divided by 0.02 squared. Right?
I think. Wait, because the margin of error. Wait.
Margin of error is 0.2. So let's see. That was the 1.96. So divided by 0.02 and then squared. So the sample size should be 9,604, I think. And we can always test that too. What number is this? Number.
Question?
Yeah.
Question 28.
Oh, what? P-value. Maybe I'm in the wrong section. Oops. Number 28. Oh, am I in the wrong thing? never mind. Maybe I'm in the wrong thing. I thought I was in lesson 20. Yeah, lesson 20, review for exam. I thought the questions were exactly the same. Does this one look familiar? 0331. Okay, we just did this one. So the 0.19 and the 0.310. Which question was that?
That was question.
Oh, that was 26 and 27. Okay, so then suppose you had with it. Okay, so that's obviously wrong. What sample size would you need to construct? Because here are our options, right? Suppose you had been in charge of designing the study. What sample size would be needed to construct a margin of error with 95% confidence? But, you know, are you sure we don't use the z-score that's already available in here? So here's our z-score. What if we take the 1.768
Okay, let's try that.
by the 0.02 and then squared?
Wait, so are you sure that's all we're needing to do is 1.768 divided by the square root of 0.02?
Sorry, say that again.
Did you say it's 1.768 divided by a square root of 0.02?
Divided. Oh yes, yeah. Sorry, 1.768 divided by 0.02, and then squared.
For some reason that seems so like simple to me that I don't see.
Yeah, well, I don't think I have that right either, because that's none of the above. Maybe I have the wrong.
Well, because so we know that the margin of error is.
Oh, and then you multiply that by the p times 1 minus p if you have p, which we do, right?
Well, wait. Margin of error, isn't that p times 1 minus p
times the z-score.
divided by the, oh yeah, all times the z-score. So z-score times the square root, p times 1 minus p divided by the sample size, right?
Divided. I don't have the sample size. We're trying to come up with a sample size. We're trying to find the answer for the sample size, right? So.
Oh yeah, that's what we are. So we want sample size to be separate. So we do m divided by the z-score is equal to square root of p times 1 minus p over n. And then, so we take that and we square it all. So then that separates it. So margin of error divided by z, all of that is squared. That equals p times 1 minus p over n. And then you want to separate the other, so you times it by.
I'm so confused.
Sorry.
No worries, Jewel. Can I can I have just 10 seconds? I'm so sorry.
Oh, you're good. You're good.
Okay.
I'm leaving, don't worry.
I will be right back.
I'm leaving.
Hi. No, I'm doing my homework. was doing my homework, look. Or my group. The nail polish is over there. You thought I was busted.
Little poop sticker.
Why? Because I was doing my homework and not biting my nails. I'm just struggling. Do you get this stuff? Look at this. Check me out.
I don't know what you're doing.
I'm doing crazy stuff.
What's the equation?
So basically, here's the equation. So margin of error equals the z-score times the square
What
root.
equation are you looking at? Here, let me see by you.
1 minus p over n. So I want to get n by itself. So I know that first I need to divide it all by the z-score. So margin of error divided by z-score equal to square root of p 1 minus p over n. And then in order to get that square root off, I need a
Square.
square root.
I know that, yeah.
And then, so I have that. And then the last thing I need to get n by itself, don't I need to do like something like that? Right?
Okay, I'm so sorry. Sorry. Okay,
You're good.
tell me again. So do you want me to show you what I have in my notes, or did you find it?
I'm trying to find it, but I don't remember where it was at in the notes, so I was trying to figure out what the formula was on my own without looking it up by getting n by itself, and it's not working for me.
Okay, so I will. Oh, I'm a mess. I'll show you what I have. If you can read my handwriting, you have really great handwriting. So hang on. Can you see me? Oh, never mind. I have to turn on my thing. Okay. So can you see? Can you see this?
A little blurry.
Okay. Tell me if you can see it.
Oh, there it is. There it is. Right there. So n equals
So the n equals a z-score divided by m squared, and then times that by the p 1 minus p, and that should be the sample size. Can you see it?
that makes sense because okay, and then I think I was almost there. The last thing I needed to like flip it.
Okay.
Yeah. Okay.
Crazy face. Okay.
Yeah. So now that we have that, let's figure out what this is.
Okay, so
Where's the
I'll
number?
write in Excel too, so maybe that will help me a little bit because I drive myself crazy. Okay, so we need z-score. The z-score divided by I have to look at my notes again. By 0.02. So then we want to take basically times 0.08, right?
So 1.768 is the number we're using, right? Or are we using the 95% confidence interval one, the 1.96?
I was going to use a z-score from what our actual numbers were because we have an actual
What
z-score.
it's supposed
And
to. Okay.
we got that z-score from using a 95% confidence interval. Does that make
And
sense?
what both of them are to compare it?
What?
Never mind.
Are you, sorry.
No, you're good, you're good. So we want to divide it by 0.02 and then do all of that squared, right?
Yeah, I'm so confused. I don't know if that's working. It doesn't really come up with a good number. That makes
Can you share your screen again so I can see the options, the choices?
On the notes?
Yeah, on the prepare, since you have
Oh,
that one.
oh yeah.
Do you still have it up or no?
Oh yeah. Did it not share?
Yeah, I'm not seeing it, sorry.
I'm sorry. I guess I didn't get that far.
Oh no, you're good.
Better?
Yes. Okay, I guess I'm getting a big number like the options, but I'm not getting the right one. So I'm gonna try it with the 1.96 and see what I get there. Because I do think that it does need to be a big number, because in order to get a small confidence interval like that, or a small margin of error, it does need to be a big sample size. So what's
So P is. Oh, hang on. Okay. So this is when I just do dumb things. So what we do is 0.16. So
Do you mind, sorry, when you have a chance, going back to what the options are again?
oh yes. Sorry, am I making you dizzy yet?
No. So I'm actually getting B, 1537.
Okay, will you tell me what I did? Because I usually do something really stupid.
So I actually, instead of using the number that they give us from Excel,
You did 1.96.
I did 1.96 because that's what it should be with a 95% confidence interval.
Uh-huh. And then you divided that by 0.02 and squared that, right?
And then I already figured out what P times 1 minus P is, and that's 0.16. So I got my answer squared times 0.16. And then I got 1536.64. And because it's a sample size, you can't have a decimal of a person, so I just rounded up to 1537.
Okay. I don't know where I keep missing this part. Really? Ah, sure. When I walk through it, then I get that one. I get 1536.64. Why? Why is
Well,
that?
I think last time we just forgot to square it and times it by the P times 1 minus P. I think we were just doing the z-score over the margin of error last time.
Oh, that might be.
At least that's what I was doing. Sorry.
Okay, whatever I was doing was very wrong. That's all I know. Okay. I feel good about that. Suppose you wish to see if there's evidence that graduates of one of the top 10 business programs performs better than other investment managers. Conduct a hypothesis test.
I'm getting second from the bottom because when I hear the word better, I think greater than.
Better. I agree. I think, in fact, I already answered that one in my notes, I think. So, this one, right?
One second. Let me go just so I can see your screen. Which one?
This one.
Yeah, that's the one I picked too.
What requirements must be met?
Isn't it The first one?
That's what I was thinking.
Okay. Oh,
Yes.
wait. Now I have to plug it back into Excel again, right?
What are we plugging in?
So it's still with what we got from 20. Oh, wait.
Are we still using that information?
I don't know what information we're using because it's saying
I wish that this was bigger. Like it's
suppose you wish to see if the evidence that graduates one of the top 10
Oh,
performs
yeah.
better.
That's our information up here, right?
Mm-hmm.
Outperformed investment managers. Okay, so we would use what we had in Excel, right?
I think.
Need this, our test statistic, the 1.768.
Sorry, I'm just trying to. So the next 8 questions. 1, 2, 3, 4. Yeah, so it's still using the information that we got from question 26. The recent book noted that only 20%.
Okay, so then if we go back, am I still sharing my screen?
Let me see. Sorry, I have to go back. Yeah, you are.
Okay, so then we said greater, right?
Greater than, yeah.
Change that to greater than, which changes our p-value to 0.039.
And our test statistic is just the same as the z-score, right?
Well, the actual test statistic would be our z-score that we came up with.
And it's the 1.768?
68.
Okay. And then what did you say the p-value was again?
0.039. I hope I'm plugging this in right.
So because 0.039 is smaller than 0.05, we reject the null, which means, what's the question? Is there sufficient? Better. So then I'm saying yes, I rejected the null, which is the first one, right?
Sufficient to conclude that better than investment. Because we were trying to say that the investment managers perform better. What were we trying to say? Let P be the true proportion of investment managers who outperform. Business program. Oh, yes. So investment managers are our null hypothesis, right? They usually outperform, but we were trying to say that graduates of one of the top 10 business programs perform better than those investment managers, right?
Yeah.
Am I saying that weird? So,
I think so. So rejecting the null means they do perform better. So is there sufficient evidence to conclude that graduates from the top 10 business program perform better? And I say yes because we rejected the null.
was only 20% of the investment managers outperform. The value is, and the p-value is so, but I'm sorry. I know I'm overthinking this. 5, so it is. No, I think you're right. I think that's right. I just get so confused. Like I just, it's too hard.
I know, I feel you.
Okay. So, I put it in. Okay, so which one are we going to use? I guess that's the question, right?
I'm not sure. I just really got the blue thing opened up. And then
Got a crack in the hose. I gotta come back tomorrow and cut it off.
Oh no.
We put it back in and then the cap will fine. That's it.
Oh, okay. Okay.
Not gonna do all that.
Okay. But, well, bye. My fridge is in it's this fridge situation. It just has to go.
what was that?
It's terrible. The fridge situation. It just has
I'm sorry.
What do you do? Okay, so which are we using to see this? Sometimes I just draw a blank and I just don't understand.
I'm struggling to.
Okay.
But it looks like it's all from to compare.
Blue scores a number ranging from 0 to 1.
It looks like it's all from the same thing. Oh no, never mind. It's different.
As a population mean score.
Oh,
So we need to find. I'm sure I'm overthinking this. So So is this a one? I guess we have to figure out what type of test that is, right?
yeah, and that's where I'm stuck.
Okay.
I'm finally getting to pulling up all my Excel sheets is what I'm doing right now. So I'm gonna look to see where it fits the best.
Okay, so I guess it'd be good to look at the information, right, in the blue scores. Yeah, which it looks to me like it's just one big pile of data, right? Just one sample, right?
I'm thinking so.
So
So would it be a proportion? No, it's definitely a one sample t-test is what I'm leaning towards.
okay, that's what I'm putting it in right now as, right? So the null
Okay.
hypothesis is
Isn't that usually One second. I'm putting it in. Or I can read it to
If
you.
it differs, so it has to be not equal to point.
Oh, is the null 0.295 is the null.
Right. So am I still sharing my screen?
Yes.
Okay, so that's what I entered. So the null hypothesis, 0.295, not equal to, I added all my variables over here, right?
Yes.
He wants to see if it differs. Let's see if it's different then. So I think that that's right. I think that's the right test to use for that. I have 95% and confidence level. So that would put our, if I have it right, that would put our lower bound at 0.282.
Oh, wait 1 second. I'll put it in. You can read it to me, and then I can read it back to you. Like going through all of it. So point what?
0.282.
Okay, and then what's the upper bound?
0.293.
You said 0.293?
Uh-huh.
Okay. And then do you have the degrees of freedom as well?
Yeah, that would be 99.
Okay. And then the test statistic?
Negative point, oh, negative, sorry, negative 2.083.
Okay, and then the p-value?
P-value is 0.006.
Okay. And I think that's all we need from there. So then I can read it back to you if you want. Let me know when you're ready for all of them.
Sure.
Just because I know it's like a lot of switching between tabs, so I figured I can just.
Oh, sorry. I'm
Are
sorry.
you ready?
What are we doing?
Oh, because I thought that it would make it easier instead of switching back in between tabs to keep checking Excel. If you read me everything that your Excel sheet is saying, and then I write it down, and then you pull up your quiz, and I read it back to you while you type it in.
Oh, you're so sweet. I was doing it while I was talking to you, so I'm good.
Oh, sorry.
Oh,
Okay.
I'm slow. I'm really slow. Okay, so we're good. We're on the same page. So if it's 0.006, then it's smaller than. I have to think that. So I think smaller, then we reject, then we have sufficient evidence to say that. And
But it's different.
is I thought we were almost done. I swear. There were only like 30 something. How many questions are on this bad boy?
45. So we have 6 more.
Okay.
As long as new ones don't just randomly pop back up.
Right. Okay, so I'm going to get the information for this AM, PM, what in the world. Okay, so a study was done to test the notion that people are taller when they first, oh yeah, so this is one of those paired sample dependent whatever tests, right?
Mm-hmm.
Of the children are taller in the morning than in the evening. Define the differences as AM height minus PM height. Okay, so I want a paired sample t-test. My head is starting to pound.
Yeah, I'm so done. Like, why is it doing this?
Is it yelling at you for some reason?
Yeah, every time I'm trying to copy and paste and it won't let me. Oh, I wonder if I just didn't say like okay, enable editing. That's my problem.
Okay, so I want to make this smaller so I can. Oh, not you. Okay. And get my. Sorry, I'm just gonna copy and paste all this awesome stuff over there. I was gonna call it junk. Okay. The differences.
I'm trying to do it too, but my computer's just
That's
so
okay.
slow. I think it's just that point. It's getting old.
Okay, so
Oh,
AM height minus PM height. I can do this real fast. Don't worry. Do AM and then U minus PM.
and then since it's paired, don't we have to go through and take out all the zeros? Oh wait, there is no zeros. Okay, never mind.
That's a great reminder, though. Thank you. Okay, so the difference, I just changed this to do equals this minus this, just so that I know it's what I want it to read. This. Okay, so that we should be good, but I just want to drag it and see. Was that the same? Score 1075. Okay, yep, we're good. All right, so there's all of our information. Okay. So what do we have? Construct
Okay.
85% confidence interval for the true mean differences of heights and conduct hypothesis.
So we need the lower bound first.
Okay, so lower is 8.728.
Thank you. And the upper bound.
10.455. The test statistic, that can't be right. What's our null do we have a null hypothesis?
Let me reread it and see.
Because it says the t-score is 22.466 and that is too big, isn't it?
What does it say it is?
22.446? That's huge. It doesn't
I don't know. That doesn't sound right.
sound right at all. Taller in the morning than in the evening. The time differences is AM height minus PM height. Subtract. I don't know, that t-score doesn't sound right to me. I don't recall having t-scores that big. You?
No, I'm seeing the same thing.
Oh, is greater than? Nope. No hypothesis. I just wonder if that makes a difference. It does make a difference. Oops. Huh. What? Less than. Huh. I think I've entered something wrong. That's right. I'm missing something. Oops.
I can't find what hypothesis is. It's just trying to see if it's different than each other, right?
That's
Not about a certain number.
Yeah. I've entered the right. Oh, wait. Am I entering the right information? Yeah, that's right. There's your AM and your PM heights. So I'm just making sure I grabbed it from the right Excel spreadsheet because I open up the system.
Yeah, and I'm seeing the same thing. Mine says 22.446.
I'm just worried. That p-value is weird. It's all weird. It doesn't look right. Oh, and let's do this. Where is our... Was it in here? Oh, we don't have options. You know how we had the ABC whatever. It's not giving us that. Degrees of freedom, p-value. 95% confidence interval for I feel like I'm really missing something. Sorry. Dog is barking. Okay, is there something that, okay, let's do this. There's something weird that I'm missing here? Okay. I don't think so. I don't know. I can't make it out. But the p-value, I mean,
Yeah, I'm not finding it either. I don't know what else we would be missing in that. Yeah, that's
right,
p value too, dang it.
AM height minus PM height. And it's your AM height minus your PM height. So it can't be that. And like you said, there's no blank spaces. I feel like they're gonna get a 1. You know, I just feel like we should have something in here. But I don't think that.
We didn't switch it up, right? We like did AM minus PM. Let me pull up what it was. Yep, that's AM minus PM. I don't know why it's coming back as something different. That is so weird.
And I have it in the right one, right? It's a pure sample, right? It's the right one.
It's just odd that, like, yeah, it looks wrong, but we're both getting that. So it's not like it's one of our Excel sheets wrong. It's
Well, should we just enter what we have? I've never seen the statistic that big. Well, we know the degrees of freedom are 40. There's that. But the p-value is weird too, except, well, is the p-value, so negative 24. Does that mean
Wait,
that,
what?
so right here, the p-value, if it says e negative 24, doesn't that mean that we move the decimal over negative?
Yeah, 24 spaces to the left.
Which basically,
So it's like really tiny. It's like 0.00000.
yeah, so then that would be 0.
Yeah, which that doesn't sound right to me either.
So sometimes it's 0, but then I think when you get a 0, it's just saying that, I can't remember. Like there's, probability is a 0. I know there's an answer to it. Like when 0 is in the probability, then I am not finding it. Well, I mean, I guess no matter what, 0 is going to be less than 0.05, right? So then we rejected the null. Is there enough evidence?
Yeah, so I'm saying yes because we rejected the null. And I think I'm just gonna admit mine because I can't figure it out. I'm sorry.
No worries. I just go back because I feel like I've just done something silly. So did you enter the 22.446 in your test statistic?
One second. Okay. So the p-value is right. It's 0.000. We did reject the null. That was right. The degree to, and the test statistic is 22.446. That was right. Let me see which ones we got wrong. It looks like we did get some wrong. Okay, so question 37 test statistic was wrong. The negative 2.083.
The 37?
Yeah, it says that one was wrong. And
Down, right? What was the score? How bad was it?
what did you say?
What was the score?
I got an 81.40%. So there was a couple that I missed, and I'm just trying to find them. So 37, I said negative 2.083, and that's wrong. And then I already told you about that one. And then another one is, gotta scroll up and find it. So question 23, calculate the p-value for this hypothesis test. Assume the requirements for the test are satisfied, and I said 0.080, and that's wrong.
Okay, so
and question 22, the test statistic, I said 6.751, and that's wrong too, apparently. And question 11, the one we thought we were going to get wrong, where we put there is a 95% chance that the true mean is between 10 and 20. That one's wrong.
Of course. Number 11?
Yeah. And I think we did get 9 and 10 mixed up with the p-value and the level of significance. I think the level of significance is supposed to be the probability of rejecting null, whether it's true or not. And I think the p-value is supposed to be the probability of observing a sample statistic more extreme than the one actually obtained, assuming the null hypothesis is true, because we got both those wrong. So I think we just got those mixed up. And then question 8 is wrong as well, where we said with the Oreos being independent. So I think that one's supposed to be paired, actually, which is weird to me, but well.
Okay. Or is...
And it looks, oh wait, and then question 2. So the very first one where we said ANOVA, that is also wrong.
Okay, so... One set of data compared.
I think question 2 should have been chi squared. Because now that I'm rereading it, it looks like categorical.
Is independent of the country they are from. You think it's the chi?
Oh, for question 2,
Uh-huh.
I'm thinking it's chi squared.
I think
Because now that I'm rereading it, it's saying like, did they do a successful startup company? And it's between yes and no. So I think that's chi squared.
I think that we had to get our brains back in the swing of things. Okay, so then number 7 in the Wall Street
Seven.
Journal.
We got 7 right. That is confidence interval. It's the Oreos that we got wrong.
Oh,
We said independent, and I'm thinking it's supposed to be paired.
okay, so let's do this. I think a way to do this is to look at our Excel spreadsheets and think if we have a sample of 55 double stuffed Oreos, we measure the amount of filling in each one. Do you want to know? Let's see, twice the filling. No. Take a sample. So we're only taking one sample of double stuffed Oreo cookies, right? To measure the amount of filling in each one, you need to construct a confidence interval. So you want to know. So which one are you thinking?
Yeah, I'm thinking it's.
Is it the one sample T confidence?
Well, I think it's comparing it to. It's comparing double to non-double, right? So I'm thinking it's paired.
Well, I would say that, except you don't have to rely on one answer for the other. So, like, we aren't taking one Oreo and subtracting the second Oreo to get our answer. Does that make sense? We're doing it as a whole. So you create your sample size and create your sample, and then you compare that to a population, or do you know what I mean? Like, does that make sense?
Oh, gotcha. Yeah, you're right. So yeah, that does seem like the one sample. Gee, because we did a problem like that later on down. It gave us the mean that we compare it to.
Mm-hmm.
Which one was it? It was the blue thing.
Oh, the Pharaoh,
Yeah, Pharaoh. It gave us a list and then told us that he was comparing it to something else. But instead of us actually typing in the other one's numbers, it just gave us the mean that we used as the null.
right, which would be like the population, right? Is that what we're thinking? Like you're comparing it to.
Mm-hmm. So I think that you're right, that it is the one sample test.
Okay. So then 11. Oh.
The next one we got wrong was 9, and I think it's just supposed to be probability of rejecting null, whether it's true or not. And then 10, I think that's supposed to be probability of observing a sample statistic more extreme than the one actually obtained.
So then 11. I hate that question. Dang it.
I still don't know what 11 is. So if you find out after you submit your test.
Data are between 10 and 20. Yeah, because I figure if we change these and then I can submit mine and then before you submit yours. So, I'm told to report just by saying something like, so you've created 95%. So is it the sample means are between 10 and 20?
It's what?
I don't know. I get so confused on that one and I hate to mess you up. 95% of all 95%. No, that can't be. So it's not the second one. 95% of the data are in between. I kind of think it's got to be the first one then. No, I don't know. I just have a hard time with that.
Yeah, I don't know what it is. Sorry.
I think that one is the first one. So that's what I'm going to put, and then I'll just see what happens. So then 22, right? Let's see. What did I do here? A survey was conducted of 12% randomly selected adults 18 and older.
22 is wrong, but I don't know why. Right.
So this is our G, right? Our G test. Let me pull that back up. This is okay. I'm not sure why I did that one. One person and even person.
Those ones I don't really know because that's what we like saw on the Excel sheet, so I don't know what we'd be typing in wrong, you know?
Mm-hmm. Oh, 131, 160. Well, okay. I'm so sorry. I'm pretty sure that's a typo. Because I had 164 instead of 167, and that actually changed our test statistic quite a lot. So from 6.5 or from whatever we have there, it's 6.579. So I apologize.
And then I'm guessing that changes the p-value as well, huh?
Absolutely. I'm so sorry.
No.
0.087. So sorry.
I'm not mad. You're good.
Of just making dumb mistakes like that. Okay, so then I need to go back to this awesome blue scores thing.
And then after that, 37 is the last one we got wrong.
Okay, so the blue scores, which one are we testing on that one? The quantitative? No, that is, was that the one sample? We use the one sample t-test for that one. And we got everything else right? So we got the upper bound and the lower bound. So not equal to, I wrote that down right.
We even got the p-value right. So I don't know why the test statistic's wrong. Is it maybe not negative? Maybe it's just 2.083?
I don't know. It has a negative by it though. Okay, so I don't know. I don't know. I put everything. I don't know. negative 2.80. Oh, what? Oh, wait, that's right. So what do we have? What's our answer? Negative 2.803. I really don't know what the answer
Oh,
is.
you said negative 2.803?
Yeah, that's what I have in mine.
I put a negative 2.083, so that's probably why I have it wrong. Yours is probably right.
Oh, okay. Okay, I'm going to save all these and I'm going to submit them and we'll see if we did better and then I can walk you through and give you all of them again since we did our.
That would be awesome. That's so nice.
Okay, let's. Oops. 95.35. So let's figure out what in the world.
Which one does it say is wrong?
I don't know yet. Oh, it's that dang question 11.
Oh my gosh.
It's 9 and 11.
9 and 11 is wrong?
Yep, and I think that's it. 9 and 11.
So 10 is right, the new one that we got for 10. And we said 10 is the probability of observing a sample statistic more extreme than the one actually obtained, right?
Yes.
And then 9, so you said 9 is wrong? And you said that's the probability of rejecting null, whether it's true or not?
Yes.
We know it's not the probability of observing. So it's what? The probability of obtaining of the type 1 error, maybe?
Let's see.
Alrighty, I'm gonna retake it, and then do you want to walk me through it if that's okay?
Yep, I'll give it to you right now.
Thank you.
Except for the wrong ones. So 9 and 11, right? We've got to figure those out. Okay, so question 2.
I'm still trying to open it up. Sorry, I should have done that while you were submitting yours, but
That's okay.
I was curious. So still loading. Okay.
Oh. All right, I think I'm going to leave my score after this because I should be in bed. I'm going to be up at like 4:30 tomorrow.
Okay, so 2, we decided that it was the chi one, right?
Yep.
And
Test of 2 proportions.
3. Oh, what was that?
Test of 2 proportions.
2 proportions.
Or test of 1 proportion. 5 is paired samples t-test.
You said, what was it? 1 sample t-test?
For number 5?
Yeah.
It's the paired samples t-test.
It keeps cutting out. You said paired samples?
Yep.
Okay, great. Sorry.
That's okay.
And then 6, we said that was, that's paired, right?
Yep.
Samples T confidence interval. And 7.
The last one.
8
is the second
we said
one.
that. Yeah, thank you. And then 9, we got that one wrong, and so I'm just gonna click probability of a type 1 error. And then question 10, we decided that was the probability of observing a sample statistic more extreme than the one actually obtained, right?
Right.
The third one?
Yeah.
And 11, we know that it's not the first or the last one. So
Done.
I'm just going to say 95% of all 95% confidence intervals
Okay.
just to see what it's going to be. 12, what was the number you got there?
12 is 0.30.
What was that?
0.30.
Oh, yeah, that's right, because it's the same as the T. Standard deviation.
0.046. Sorry, did you hear it?
Yeah, 0.046.
Yeah.
And then the next one was
139.
what was that?
0.139.
139. 15. Margin of error. What's 15 again? Sorry.
You're good. 0.016.
0. Oh, and this is like the next one is negative 0.003, right?
Yep.
I remember some of these. And then the upper bound is
0.029.
0.029.
Uh-huh.
And then 18.
Is the first one.
Oh, yeah, different. 19.
0.458.
What was that?
1.458.
1.458. P-value.
The p-value is 0.145.
Question 21.
Sorry, I'm just plugging in my phone. 21 is the last one.
Thank you for taking the time to do this.
Oh, no problem.
And then 22
is 6.579.
0.65. Wait, what was it?
6.579.
6.579.
0.087.
0.087.
It's 24 is the fourth one down.
No, the p-value is greater than 0.05.
Yep. 25 is the last one.
$26.
0.190.
What was it?
0.190.
0.0?
Sorry. 0.190. I don't know why it's breaking up so bad for you. I'm sorry.
No, you're good. It's my computer, I think. 27.
0.310.
Point what again?
Sorry, I'm trying to get my kids to bed too. Which number? Which number was it?
Question 27.
Oh, 0.310.
It keeps cutting out on the same number.
No.
I got 10, but I'm pretty sure there's something in between that.
So 0.310.
Perfect, thank you. Sorry. Okay, 28. What is that?
1537.
7.
It's cutting out for me too now. 1537. and 37.
Okay, that's what I have.
Um,
And then this last one, like the second from the bottom, right? Not last one, but 29, second from the bottom.
yep.
Okay, and then 30 was the top one.
Yep.
And then what was 31?
1.768.
1.68?
Nope. 1.768.
0.768.
If I share my screen too, would that help if you needed to flip over and look at it?
Maybe. Yeah, let me
I don't know if that'd make it
see if
hard for you.
I split my screen so I can look at yours and fill this out. We'll see.
Oh, I have to go the right. Well, goodness gracious, I don't know where anything is. Okay. So 32 is 0.039.
0.039 is what you said. And then
30 is the first one.
first one. And then 34.
0.282.
Oops. Does it say 0.293?
Uh-huh. The degrees of freedom are 99.
We're almost done. 37. And that's what I got wrong the first time, but it's negative 2.803, right?
Yes.
And then 38. What does that number say? I can't see it. Oh, it's because it's not scrolled down. Yeah.
Oh, sorry, 0.006.
Don't be sorry. I just thought that box was a number, and I was like, I can't read that box. All right, and then 39 is the first one. 40.728, is that what it says? Or is that
8.7.
all right, 8.728?
Yep.
And then 41 is that 10.455?
Yes.
$42 is that 22.446?
Yep.
Oh wait, did I skip one? 3 is 40? Is that what that says?
Yes, sorry. I think it might be easier to read than to try to say because it cuts out almost every time.
44 is 0, and then 45 is the third one?
Yes.
Oh, thank goodness. Do you want me to see what I get for those two questions?
Sure, yeah. I can wait.
Sorry, I know you're trying to get your kids to bed. I'm sorry.
No worries. I think the day is just catching up to me.
I know, it's like already 10. What has happened? Oh, that's actually 100. So, did you want to try again, or I don't mind reading it to you?
No, that's all. I'm so tired. So I did get, so it was a type 1 error, so I'll make sure that I'm aware of that. And 95 of 95%. Who would have thought? That's bizarre. I don't recall ever.
If you have a question like that on the test, that's what it is.
Gosh, crazy. Okay, awesome. Thank you very much. I will go ahead and post this really quickly before I go to bed because I don't want to forget.
Is there a spot to post this on?
Oh, do you know what?
This
You're right. never like that, but that's okay. At least we did it, so that's good.
Okay. Well, thank you so much. I really appreciate all your help and for going through it a second time with me. I appreciate it.
No problem at all. I appreciate your help. So have a good night and good luck to us, right?
Yeah. Yeah, good luck. I'll talk to you later then. All right,
Bye.
bye.